this is a Jupyter notebook. As you see, you will also receiving a link that I will share now in the chat, which is a repository containing this Jupyter notebook. I just have to find the chat. I don't find it right away. I'll do it later then, I guess. But anyway, so you'll be able to reproduce that Jupyter notebook that we're going through. And it should be runnable quite easily. There's some installation guidelines to it. And then you can reproduce all of that we're going through by yourself afterwards if you want to go through internals again and try to understand and recap. So what's the PyPSA statistics module? The statistics module is something that we came up with, I think now 2 or 3 years ago, in order to make things a bit smoother in PyPSA when it comes to the analysis. So let's say we start here with the motivation. Let's say you have a colleague, a nice colleague of you who is actually giving you a task. He's sending you over a PyPSA network and he wants you to inspect it and tell you something about it. Perhaps what's the behavior, what's the capacity, just really getting a feeling for it. What's happening there. You know, these PyPSA networks, they tend to be very complex when it comes to multiple buses and sectors and whatever. And then you want to have a good understanding of it. So really, this colleague is asking you to understand it. So for that purpose, we're now imagining this colleague sends you over a carbon management PyPSA network, which we now pull here from the examples, and you load this into your Jupyter notebook or in the shell that you use. Perhaps it's an IPython notebook, and you're seeing, okay, what's that PyPSA network now? We loaded this into N. And how does it look like? So the object itself tells you something about this, and it says, okay, there is 2,164 buses in there. Oh, this is quite a large one. And there's multiple carriers, and there's a lot of generators, and so on and so forth. So you see, this is a whole thing, which is very complex. With these loads of carriers, there must be a lot of things going on. So how would you do that? You probably then have a look at the buses and you see, okay, what's actually the buses? What's the carriers here go? Okay, you probably got some information from your colleague. Okay, this is a carbon management network. So yeah, there is a lot of carriers here. We're dealing with various energy forms. Now here we have heat, we have water tanks as a technology, we have AC, so electricity, we have CO2 and so on and so forth. Okay, then you might have a potential chain of thought. How do I inspect this? There's really a lot of things going on. Okay, let's start with generators, pnom, and group by the carriers. Then perhaps, yeah, let's do that again also for the links. Then you think, okay, yeah, there's also stores. Yeah, I should do that as well. Wait, stores, they have a different attribute that I should inspect. It's not pnom, it's enom, right? Yeah. Wait, it's not pnom, it's pnom opt and enum opt that I should look into anyway. So you see, there's these chain of potential things. I had these like hundreds of times. And then I am there and I find myself again and again, the same situation where you have this network and you want to go through the different components and you want to just to know what's the installed capacity, what's the optimized capacity now, and just to get some reporting on that. And so in order to not do that manually by yourself, which is often cumbersome and it's often a bit error prone and verbose, we have created the statistics module. So what is it? When you first run the statistics model, and I'm sorry, I already have all the outputs open because I just ran it already. You have the big access point, which is n.statistics. n.statistics happens to be a function. You see, you can call it here. But on the other hand, it's much more than that. So let's call it, and afterwards we're seeing what else it can do. When we do that, it's already running here. It is producing a table. And you see, it's a large table. So on the top, we're having columns which indicate different stuff. So there is optimal capacity, install capacity, supply withdrawal, energy balance, and so on. On the left-hand side, in the index, we have a multi-index, right? We have multiple levels, where the first level is indicating what component, PyPSA component are we actually talking about, and the second one is giving you the carrier of that component. So here we're looking at the generator biomass carrier, and now all the biomass carriers and generators aggregated, and they have an optimal capacity of what's that? That's 90 terawatts, I guess. Or is it gigawatts? I guess it's gigawatts, 900 gigawatts. And the same for supply, withdrawal, and all this stuff that we're seeing here. So really a big aggregation table that gives you an overview of the different things that are there with respect to the different components and carriers that we're having in our PyPSA network. So this is helpful, but it doesn't give us the whole story, right? We sometimes want to know, okay, what's actually happening with the capacity? Okay, we know there is a lot of biomass now, but actually, where is this biomass placed? And where it is perhaps, how is it operating? So all that stuff that might come up as natural questions, the statistics module can also help you with that. So I already said it's not only a function, it's also an access point. By the way, there's a tip here coming. Nstats is an alias for nstatistics. So for all the times when we're using nstatistics, you can also write nstats. It's just a shorter way. I'm just, for now pedagogical reasons, keeping it as nstatistics. So we really know what we're talking about, so this doesn't feel all new to you. This nstatistics thing, it has a layer which is after the statistics access points. So after writing in statistics, you can continue with a dot, and then you have a whole lot of functions that you can call. And we will see that in a second, but for now, let's see what's there actually. And there's different categories. So here in this table, I summarize what functions are there. And there's functions for costs, which is capex, install capex. We already saw that here at the top. But now we have sort of access points which go into these columns, which we have in our overview table, and we can go deeper into this direction. So the capex, installed capacity, expanded capacity, OPEX, and system costs for the costs. And if Cora doesn't mind to mute his or herself, then we wouldn't hear some noises there. Thank you very much. Then we're having the same for capacity, which also is mirrored and reflected in the table. We're having the same for energy, supply, withdrawal, energy balance, transmission, curtailment, and market and markers, indicators, prices, revenue, market value. So it's stuff that you might be interested as a user which works with these PyPSA networks. And this list might be expanded, and we will expand it in the future. But this is what we're having for now. And we're going into these functions one-on-one. And these functions not only come with reproducing what we had in the table, there's a lot of parameters that you can pass to the functions. So the first one that you probably realize is there's a group by argument. Oops, I'm sorry for this. It's just for a reminder for myself to be relaxed and relaxing my eyes in front of the screen. So there's a group by argument, and you know that it's as sort of the same as you know it from pandas. And what's happening as a default is that we group by a carrier. So for each component, you remember there's the generators, link stores, and so on. In the first level, we group by the carrier, which is then aggregating all the stuff that you're interested. But you can pass various things there. We'll see that in a second. There's a group by method that tells PyPSA how to aggregate across these groups that are identified. So either we sum over them or we're taking the mean. right? It might be that you're interested in the average capacity per generator of a solar technology. And then we have, when it comes to time series and aggregation of time series, we have also different options that we can pass. So this is done by the group by time argument. So there, for now, we're supporting sum, mean, or false as the aggregation of time series, where false will just give you the whole time series in a non-aggregated form. And there, really, you have to think about two different dimensions here. So group by and group by method is applying to the components aggregation and how to aggregate the components and what's the method and how to aggregate it. And the group by time is about time series, where we have sort of dynamic data that we then aggregate into either points or keep it as a time series. As a fourth argument, we're having the components specification. So you can pass there a list or a scalar of the components that you're interested in. So this is PyPSA components. It can be subset of generator, link, line, and storage and store. We'd see that in a second. It's probably not so interesting because you most of the times want to aggregate over all the different components. Then we're having our carrier that we can specify. So this is really the carrier as a specification kind of what technologies are we interested in. We have the bus carrier, which we'll see in a second. I'll explain that later. And we have just another optional argument, which is taking the nice names referenced by the N carriers data frame or not. Okay, this is an overview of all the different parameters, and you might have recognized if you're using the statistics module that these two, I guess, perhaps even the first three, they have changed over time now with the new release with PyPSA 1. It's a bit more structured argument names, I would say. Before, I guess, we had some different argument for the group by method. I think group by was called differently. I can't remember right now. Anyway, there's another function, just by the way, which is called prices. It's a new one. It's not totally harmonized with all the arguments. You can keep that in mind if you're using that. So let's see it in action. Let's come back to this carbon management network that the colleagues sent us over. And we now have this overview table now. Okay, statistic nice, but we want to go into the cost analysis now. Okay, what's the capex that was installed and the OPEX and the system cost? So capex is the installed capacity and the expanded capacity together. That's sort of a PyPSA convention. And if we are running the capex function, you see mostly reproduction of what we had in the upper table, right? Here we have capex as the function without arguments. This returns a series now, and I'm just converting the series to a frame to nicely display it here. I'm getting the sort of the same things here. We're doing the same for the OPEX, and we're getting the OPEX here, and we're doing the same for the system costs. So these are how the functions are defined and run. So you always have this pattern and statistics dot system costs, and then the respective the other functions. Now let's apply one of the arguments that we just talked about. So the group by method. I already said that you might be interested in the average capacity per asset. And now what we're doing, we're doing a comparison between the capex, which is returned as a sum of all the costs of the technology in the network, or as an average per asset. So we're doing that with passing the group by method, once with sum and once with mean, and we're concatenating that in one pandas data frame. And you see that here. This is sort of what comes out, concatenating, and then we're just sorting by the sum value, and I'm doing just some formatting of the numbers here in order to have a nice display. And then you already see, okay, it's nice. We see there's now a sorting. Here we still see the component level and the carrier level. Now we have the sum and the mean as columns. And this might be of interest for you just to check, okay, there is quite some solar here. This is the most invested technology in this network. And per asset, we're investing really 1.5 roughly million euros. So it's quite something. You remember, I guess we have something like, I can't remember the number of buses. If I scroll up, I have it here. It's 2,000 buses. This is containing all the carrier buses. So I think the spatial resolution is something like 90 or so. So you can say for all the 90 buses, yeah, we could probably derive it. Yeah, we could just here divide it. For all the 90 buses, we invest in 1.5 million euros in solar, and the same for wind. And then we have some significant gas store investigations, and so on and so forth. So this gives you a good first overview of how the cost investments are actually taking place into the system. Now, there's other groupers, right? So we now use this group by method thing, but we also have this group by argument. And if you have a look at the PyPSA internals, you find there is an argument which is called PyPSA statistics groupers, and this is giving you some sort of information of what groupers are actually available in PyPSA. So it's not only carrier, it's a lot of them. If I run this again, I see there is a bus as a grouper, there's a bus carrier as a grouper, interesting. Carrier, country, location, also interesting. So some internal things that happen to be there, already supported by PyPSA, that we can use right out of the box. Now, this comes with a small disclaimer. In order to have these running properly, your data model for sure must know what a location is. So you have to have these specified. And if you want to take the location as the grouper, you have to have the location columns in your PyPSA network defined, right? It must not be empty. If it's empty, probably it will aggregate all of them together and just say that's my aggregation point. It's sort of the same value overall. If I run this as with a grouper with country and carrier, again, country is defined in our network, and the carrier, I'm running this, and I'm getting now multiple levels here, 3 levels in my index. I'm again converting this to a frame just to have that nicely displayed. We see now there is a level coming up, sort of appended to this index, which is now indicating the country. So we still have the carrier as an index level, but the country is also now specified. This is nice. We can now see the offshore wind installation costs in Albania, for example. And this goes on and on and on. This is quite a large data frame. I guess we could do something like we're dropping. Now you can play around with this. We can probably drop, is there underscore drop levels? I'm not sure. Is that working? Probably drop level. Yeah, like this, without an underscore. And then we could probably even unstack it, right? So we make, instead of an series, we make a pandas data frame out of it. And then we have quite an intensive or a dense information about our CapEx installations, right? You have the countries on the left-hand side and the technologies on the top. So I leave this there. You get a feeling how you can use these group by arguments and how you can play around with it. And again, as a reminder, whenever you have questions, also write them down into the chat so we can keep track of them, and then at the end we discuss them. We have a a 50 minutes Q&A at the end. Now you have let's say you inspected these tables a little bit more, you know what's going on with the investments and the OPEX and so. Now you know, okay, there's how this is how the costs distribute, but now this is not totally reflecting the capacities. Let's also have a look at the capacities. You can also do that with the statistics module. And the one that you're mostly interested in probably is the optimal capacity function here. I already said there is this installed capacity function, but this is for pre-installed installations. Sorry, pre-optimization installations, right? So after the optimization, we want to know what was now optimized, what's the capacity investments that are optimal. And you do that with the optimal capacity function, I said, and you get the same resolution here again. So again, you can use all of the group by arguments and group by methods that we discussed already and have a look at these. Now, when it comes to the capacity, you probably encountered this. There's sort of different capacity units that we're talking about in PyPSA. Sometimes we're talking about dispatch capacity. This is a generator, has a peak capacity, and this is sort of its dispatch capacity. It can produce that much power. But there's also storages and storage units, and they have a storage capacity. So if we summarize that in the table, you notice, okay, generators, links, line, and transformers, they actually have only dispatch. They're producing power or transforming power or transmitting power, whatever. And there's the storage unit, which has sort of both. It has a P num value, so it's a dispatch capacity, but it also has an internal E num, sort of a storage capacity, which is the max hours multiplied with the P num opt. And then you have the storage's capacity only component, which is the store. So this has an enum and enum opt value. Sorry, I have to cough. Excuse me. So these components and the unit difference, they are reflected in the statistics module. And per default, we're giving out dispatch capacities. This is just for convenience, because you're most of the time interested in dispatch capacities. But you can pass a argument, which is called storage. And I'm sorry again. Really got a bad cold from my son. So here we have a storage argument. I'm sorry, guys, I have to get something to eat to calm my throat. I'll be back in this.
Okay. While we're waiting for Fabian, if you have just a quick reminder, if you have any questions, you can submit them to our Slido link. The link was given in the chat. Fabian, are you also planning to send the Jupyter notebook link to the participants? I think you're muted.
Yes, thank you. I
Okay.
am. I just have to find the chat in this presentation mode. I can't see the chat,
I
unfortunately.
think you can click on the chat there. At the chat, you can see the chat.
Yeah, in presentation mode is sort of a bit weird. Perhaps I'm sending it over to Charlotte, and then
Okay.
she. Here is the repository. I'm sending this link over to Charlotte, and then she can send it in the chat.
Okay, great. Thank you.
There we go. This is sort of a repository that I yesterday created. It's just called PyPSA training sessions. And it's containing now just the code for this session, which is the Jupyter notebook that we're essentially looking at. And yeah, so this, if we have follow-up sessions here, I'll intend to also place them here. You can just run them by sort of UV on Jupyter Lab or Jupyter Notebook. It's quite straightforward. So I'm really hoping my throat is now doing its job, or my voice at least. We talked about this storage argument here. You can set that to true for all the capacity functions. So this also works for installed capacity and for other capacity related functions. I think even for no, not for the cost ones, only for capacity, where that makes sense. And if you run it, then you see there is different numbers coming out. So it's scaling mostly with so the cost, it's sort of now referencing the capacity is now referencing the storage capacity. So for the storage units, you would see there you have this max hours argument, and now it's scaling the capacity, the dispatch capacity with these max hours internally, and then it's returning this. For the stores, it's just using the enum opt value and aggregating this. So it allows you really to run all the aggregations that we talked about in storage in terms of storage capacity. We have another one, which is the capacity factors. And there it's also quite straightforward. It's a function that you can run and that gives you a sort of a unitless number between 0 and 1, which indicates what's the average operation. So I guess you're mostly familiar with the concept of a capacity factor. And most of the times you would have to write that or calculate it manually in PyPSA. So you get the operation time series like the P, and then you divide that by the optimal capacity. And you'd have to do that for the links and for all the components. And now it's running that for you. Exactly. So this is something that's quite useful as well. It's showing that this is only for links. I'm a bit wondering why. There should be as well there might be if we're doing this drop NA, so there might be quite some NANs in generators. Anyway, I guess it's not about that one now. It's also a function. I'm not so much using this one. It might be helpful sometimes to see the capacity factor, especially something you can do is you can now keep it as group by time. I guess group by time equals false. If we do that, then what it should do is returning you a time series of all the components, and again grouped by the group specification that you put in, and that's returning you the capacity factor as a time series, which can be quite handy if you think about wanting to understand how the operation in your system is actually when it comes to sort of stress to the system. So whenever there is high capacity factors of the transmission lines, for example, then there's a lot of transmission going on. Whereas for the renewables, you see there's high capacity factors in certain hours. So you get like a good feeling for sort of the relative operation that's happening in your network. And now here you can do also stuff like filtering. This you can do everywhere, but I'm just showcasing this here in this function with the argument bus carrier. So again, capacity factor, but now we're interested in all the technologies that actually produce AC, so electricity. And that convention you have to think of as sort of a topological thing. So generators are attached to buses, right? And links as well, stores as well. So all these sort of components that we're talking about, they have a collection point where they produce power to. And this collection point, the bus, has a carrier as well. So it's sort of referencing what's actually the energy carrier that we're talking about. What's the sort of the type of production? So if a generator is of carrier solar, this is rather referencing the technology, and we're rather referencing what's that sort of technology of producing the power. But it's attached to an electricity bus, then we know it is actually producing electricity because there's sort of where the output of the generator is collected. So this reference point, we call that here a bus carrier. So the carrier of the buses, where we sort of now aggregate to, and we can also filter by that. So if we say we have the bus carrier AC, we're saying now get all the components that actually produce into an AC bus. And this is very handy because it sort of directly gives you an idea of what the energy carrier is. Yeah. So rather, this comes sort of from this spatial logic where components are attached to a bus. And if you run that, we have sort of now all the components that produce essentially AC high voltage electricity. And this is now as such, we have got generators, nuclear, onshore wind, offshore wind, run-of river solar. And then, of course, we have our transmission lines. They also produce AC in sort of in a certain sense. And for all of them, we now get the average capacity factor. We see for nuclear, it's quite running on full load, sometimes probably shutting down. And then for the renewables, it's somewhere where we would expect it's quite a strong offshore wind pattern that we've seen here. 30 or 42% capacity factor is very high. That said, it's we just this example is just showing sort of a week of this whole yearly optimization. So this might be quite an wind intensive week in the system. Then of course solar is also where we would expect it somewhere. It could be better, but probably it's not summer here. And then, of course, for all the transmission lines and the storage units that sort of are attached via a link, we also see that the battery charger here, 23%, and all that stuff. So you can easily derive like things like full load hours, indicators that are very much used in system analysis, and that are linked to the capacity factor. Again, you could see that also as a time series, which might be interesting, and then you would plot it and get sort of a more dynamic relation between the capacity factors and the operation in the system. So now we talked about costs and capacity factor, and now what's sort of naturally remaining as perhaps as I would see it, if I rather come from sort of power flow analysis, is what's the operation? So we talked about the sort of relative operation here, but what's sort of the actual supply and how is the system transferring energy between buses? What's going on there when it's producing power at most, when there's backup installations ramping up, and so on. And we can see this with these functions here: supply, withdrawal, energy balance, transmission, and containment. again, that's a subset that we created, but we hope this suits you well. Um, Again, here supply, we can run that as a function from the statistics module. And we would see essentially again the same thing as we had on top in the big table, but with all the group by and group by time arguments, bus carrier and carrier selection things, you can run here as well. So this is handy, and you can imagine various types of tables that you produce with these functions. So you could think about things like what's the supply in the countries for a certain bus carrier with these carriers actually, and then you would aggregate that. The same time, so just to make that perhaps a bit more clear, supply is what components actually produce as power as energy carrier. Withdrawal is what they consume. So it's sort of the net consumption. No, sorry, it's rather the gross consumption of a component type. So when you think about a load, that is, of course, a withdrawal component, but a link can also be sort of withdrawing energy from the system, right? Or withdrawing energy from one bus and transforming it or transmitting it to another bus. So this also counts as withdrawal. And for example, you would see here things like they might look a bit obscure here, but process emissions is something that comes here as a link. So it is a thing that a link takes up from the system. It's an emission from, I guess this is now some sort of generator that sort of produces these process emissions and then puts it into the atmosphere. All right, so it's withdrawing from that process emission bus and puts it to the atmosphere. So this aggregation by carrier here in this case is not super straightforward. It's often helpful to use then also the bus carrier argument in the group by argument. And this is what also the default is for the energy balance. So there's the energy balance function. And if you run that, it's the only function that has different set of group by mechanism. And you would see it will always group by carrier and bus carrier. So for example, here it's a bit more straightforward. We already had this example of AC power production where the nuclear generator is attached to. So now it's giving you this production into a certain bus carrier per default. And this is very handy. So we find that very handy because it really gives you quite some intensive detail what generator type and what production type produced in what energy carrier. And this aggregation runs for sort of the supply and the withdrawal at the same time, which is then here combined in the energy balance. So energy balance is sort of the sum of withdrawal and supply. And there you can think about various operations that you can do afterwards as well. So XS is something that you might be interested in. Now you have a table, you can select certain things. Now you have XS as a pandas operation. So you're selecting now the AC bus carrier, but you can also think about perhaps we could here plug in something like CO2 stored. And then you would see what's actually now the energy balance in the CO2 stored sort of sector or bus carrier. And then you would see, okay, that these are the technologies that are actually producing and consuming from this carrier. Something similar and related is the transmission. This is again something spatial that you have to think about when a component is attached to two buses of the same carrier. They were talking about a transmission. So there is, of course, there is lines which are always attached to two AC buses. And then so these internal convention says, okay, if it's having two ports and these two ports having the same carrier, bus carrier, then this counts as a transmission. And the lines have that. Other things which also show up here is the links when you transport a certain carrier. For example, here the CO2 pipeline is transporting CO2. DC links, direct current links, gas pipelines. So all the pipeline types, they would show up here. So it has that really internal filtering of the components that are attached to a certain carrier at all the ports, or at least 2 ports. Containment is also something that's interesting. You can have the difference, or you know that principle, but it's all doing that by yourself, by itself. It's the difference between the dispatch and the optimal capacity and or available capacity at a certain time, and then this is counting as the curtailment. Here again, you can group by countries, carriers, whatever you think of it. Let's go a little bit further. Here we have another argument that we're using, the components argument, that we're filtering, have an example of filtering components. Now we're just running this supply function over the generator and the link component. This is something that's sometimes interesting when you have a lot of components and actually now I really want to go into the generators. If you run this as a scalar string here, then it will also kill the first level and you won't have the first multi-index level. So this is really just giving you the carrier supply of the generators now. Again, group by time faults. This is something that we already talked about. You can play with that by yourself when you have the notebook, I guess. I have to be a bit more strict about the time. There's one thing which is the one section which is the last one in the statistics module, which is the market metrics. And this contains the prices, revenues, and market values. I won't go into these by now. You can go by yourself, I guess, when you run the netbook. It's just another convenience function that is using these internal logics of PyPSA when it comes to marginal prices, when it comes to what are the actual revenues when we look at the duals of the optimization problem. So the buses marginal prices, yes, and the marginal costs in relation to each other. One other thing that I wanted to talk about is the custom groupers, and I'll touch that for, again, 2 minutes. It's something that you can tell PyPSA to group by. So we know there is these internal group by specifications that PyPSA supports, carrier, bus carrier, and you name it. But you can also register your own groupers into PyPSA. And this cell shows you how to do it. It's essentially using this groupers argument that we saw before, or this groupers field from PyPSA. And now it's adding a function, it's adding a function to it. And you register under a string with this add grouper function here. And then once you did that, you can call this grouper in your statistics function. So n statistics capex tag type, that's something which is per default not there, but we just registered here. And now we're grouping by conventional, renewable, and others as we defined it here in our mapping. This is quite straightforward. It's very interesting to play around with it, especially when you think about these multi-sectoral networks. And I guess here I want to come to an end. We have tips and tricks at the end just for you, which I personally like. So most of the times I'm using abbreviation for statistics, either S equals n statistics or this n stats as we had it before. Then you could just call n S capex and so on and so forth. We have another argument that we didn't talk about is aggregate across components. You can set that to true, and then it will sort of kill the first level of the multi-index and just aggregate all the carriers together and specify the bus carrier as much as needed if you have sector coupled networks. So you really make sure you don't mix the bus carriers. And this is, I probably should have written that down as well. You can also group by unit. This is also something that is quite interesting. You have sometimes different units attached to carriers, and there you see how the grouping actually evolves there. Recap, we have all these different sort of sub-modules in our statistics module related to the different fields that we're looking into. And you have a comprehensive guide in the PyPSA documentation. I really recommend to look at this. I guess we also have an example there. And now I want to go to the Q&A because we don't have a lot of time. As a short, very, very short spoiler here, I wanted to show you how to plot, but I guess this is something in a follow-up that we discuss at a later point in time. So yeah, Charlotte, I'm handing back to you and let's put in the Q&As.
Thank you very much, Fabian. Excellent talk. Yeah, we have received quite a few questions for you. So do you want to take some of them? Then I'll present some others. Otherwise, I will start from the top here. We have a question saying, how does the statistic models handle conventional generators models as links in a sector coupled scenario versus generators in a power only scenario?
Yeah, that's a very good question. So both of them work in the statistics model, and we have internal conventions how to harmonize them. So generators quite strong. Generators are very straightforward, right? You have one port where it's producing two, and you just take that value. A link is having two ports. And internally, the statistics, or multiple ports even, and internally, the statistics module is looking at each port individually and sort of treating it as a generator at that port. And you really have to think as of a link, sort of segmented or sectioned or subdivided into these different ports, and these different ports are looped over. And then we sort of treating that as a one port component as of a generator. Does that help with the question?
Does the person with the question have a follow-up? Otherwise, we'll go to the next question. I can see a thank you in the chat, so I think that's fine. So there's a question saying, can you suggest material for geospatial plotting using the PyPSA network?
Yeah, I guess I can. It's just a very broad field. There is also something related to the statistics module. So you can create maps with the statistics module as well if you go into that direction. I guess it's something we have to talk about in another session. If you want to have a look at it, it's called N statistics plot map, I guess. Is it that one? Energy balance, something like this. Yes, here we go. I'm not sure if that's working out of the box. Probably it's not. You have to do some specifications, some bus carrier, I guess. And then you could create I would need to look into this. I also saw there's some bug going on in a scalar string selection here. This should be working, and it will be working in the next one because I have it on the radar in the next version of PyPSA. This is definitely something that's very helpful if you want to have maps of different sectors in your PyPSA network. Otherwise, this is a whole topic we have to talk about in a dedicated session, I guess.
So now we have an idea for the next session. Great. There's a question here saying, is there an elegant way of using the statistic models to create Sankey diagrams to get the energy flow out?
Yes, you can use the energy balance function just as is and do that across, like aggregate across components, true thing. And then you have to find a function that takes this this multi-index table, which is now bus carrier and carrier, giving you inputs. Inputs and outputs. I guess you have to map these to sort of sources and sinks in your Sankey diagram. I have a function somewhere which does that. It's not officially in PyPSA. It's not super straightforward. If you want, you can raise a GitHub issue on this, and then we might think about supporting that more officially and perhaps putting in an example in the documentation. It's not super straightforward because also the scaling in the Sankey diagrams are sometimes super, super hard to do. Yeah, this is one of the big bottlenecks that I saw, at least. So we don't have it officially. I would start from the energy balance return value and try to map that to inputs and outputs as to be sort of processed by the Sankey diagram function.
Thank you. There's a question here saying, is there a simple way to commute the consumer producer surplus as congestion values when working with a multi-sectoral network?
What was the second? Consumer surplus and?
Consumer surplus and congestion revenues.
Yes, yeah, congestion revenues. Yeah, I already talked about that. We have this market, these market metrics now in, and it's still a very small selection of things here. We want to expand it as we see the need for expanding it. So this is definitely something we want to get in. The congestion revenues of course, because consumer surplus, we didn't think about it too much, but it probably makes sense. For now, it's not internally internally supported. What you can have here in the revenue function, there is an additional argument. I think it's called in and out or something. Have a look at that as well. Is giving you a bit more detail on how to specify the revenue. So this would sort of give you the revenue. It could even relate to the consumer surplus. Have a look at that and the arguments there. Definitely something I could point out now. Otherwise, I would say this is future development.
Thank you. We have a question that actually goes a little bit beyond the statistic model. This is a question of whether there's any updates on PyPSA Explorer and similar elements.
Yes, due to the lack of time, there is not at the moment. I hope I can touch it again. There is also the PyPSA app that Lukas from TU Berlin is developing, and it's just extraordinary. Yes, it's in the planning. It's just a question of when, because I see there is a lot of potential. Essentially, this Explorer, for the others who don't know what I'm talking about, it's a repo. I think I have it here. And it's using the statistics module and the plotting functionality of it, and creating a dashboard out of sort of just putting in a PyPSA network. And it's very convenient to get a good understanding of what's happening without actually going into coding. Yes, I plan to do that. It's just so much on the plate, but yeah, I really want to get this further. Thank you for raising this. Probably then lifts it up in the list of priorities.
Thank you so much. We don't actually have time for any more questions, but I will take the questions and send them to Fabian afterwards. Maybe he has some comments and some replies to some of them. I will send out the recording to everybody afterwards when it's ready. And with that, I just want to say thank you so much to Fabian. It's been really great having you here. And thank you so much for everyone who participated, for the great questions, the engagement. It was really awesome to have you joining. And I hope that you would like to join another session later on. I'm sure that Fabian has something in mind based on some of the questions he got today. So thank you very much and have a really lovely day, all of you, or wherever you are in the world.